Good morning to everyone. Today we will discuss about DC missions in gate point of view. Myself, A. Sudhakar, Assistant Professor working in SV College of Engineering. Here first we are discuss types of DC generators based on methods of excitation given to the field winding. Here we are categorized two types of generators: self-excited DC generators and separately excited DC generator. Means here the main parts of DC generator is two. One is stator, another one is rotor. The stator is represented for DC machines as in a field winding, and rotor is represented with armature A and AA. So here the field winding is separated from rotor winding. That generator we call as in a separately excited generator. The field winding connected with respect to armature or armature winding. The generators we called as in a self-excited generators. In self-excited generators, again we classify shunt generator, series generator, compound generator. In compound generator, again we classified long shunt compound generator and short shunt compound generator. Here, shunt generator, the field winding is parallelly connected with respect to armature winding and armature. We can call it as a shunt generator. The field winding connected in series with armature winding, the generator is called as a series generator. The combination of shunt field winding and series field winding connected with respect to armature winding, that generator we can call as a compound generator. See here, what is the differences between this shunt series compound generator and separately excited generator? In separately excited generator, we can adjust the field current separately. Based on that, we can obtain the generated voltage. Here, in self-excited generators, the field windings are connected with respect to armature winding. So from that, we can obtain the generated voltage in these generators. See here, suppose shunt generator, series generator, compound generator. For example, here we are going to be taken as a shunt generator. So what is the no load voltage of shunt generator is rated voltage. So what is the no load voltage of series generator is 2 to 5% of its rated voltage. Coming into compound generator, what is the no load voltage of compound generator? The no load voltage of compound generator also rated voltage. Here what is the rated voltage of DC generator means 220 volts. 220 volts is the rated voltage of DC generators. See here, what is the difference between series generator and shunt generator means? Suppose in shunt generator no load voltage is 220 volts, that is rated voltage. And coming into series generator, the no load voltage is 2 to 5% of its rated voltage. What is the difference here? Based on self-excitation, the shunt generator will produce rated voltage. See here, for example, in this generator, here because of residual magnetism, a small voltage will be produced across the armature terminals. Because of the shunt field winding, this small residual voltage is having closed path such that this small voltage drive current through the shunt field winding. Then there will be increment of shunt field flux. This field flux is added with residual flux, the net flux is increases. The generated voltage also increases. This process is cumulative until the shunt generator build up rated voltage across its armature terminals. So coming into series generator, Coming into series generator, under no load condition, there is no current flows through the field winding. There is no current flows through the field winding means only residual flux will be there. Because of this residual flux, the no load voltage of this series generator is 2 to 5% of its rated voltage. Here coming into compound generator. The compound generator here is in a long shunt, either may be short shunt. There is a uh, closed path for the armature winding. There is a closed path for the shunt field winding with respect to armature winding. Because of residual voltage, there is a current flows through shunt field winding. Then the shunt field flux is increases. This flux is added with the residual flux. Again, this compound generator also build up rated voltage across its armature terminals. So based on this, we can say that the the no load voltage of series generator is 2 to 5% of 2 to 10% of its rated voltage. The no load voltage of DC shunt generator is rated voltage. Similarly, the no load voltage of compound generator also rated voltage. So these are the voltages with respect to generators. See here, next here we discuss about voltage buildup in DC shunt generator. Voltage buildup process in DC shunt generator. Here voltage buildup process in DC shunt generator. There must be some conditions required to build the voltage in self-excited generators. What are the main conditions required to build up the voltage in self-excited generator means? First, there must be residual magnetism in the field poles, which is the essential condition. See here, there must be residual magnetism. See here, what is meant by the residual magnetism? Due to retentivity property, all the electromagnet possess some flux, even though the field current is zero. This flux is called as residual flux, which is nearly 5 to 10% of its rated flux. Here, to build the voltage of self-excited generators, the first condition is there must be residual magnetism in the field poles. Suppose if field poles does not possess residual magnetism, what we can do? Here, suppose there is no buildup of voltage takes place. Again, residual magnetism is re-establishment. The field terminals are separated and excited with low voltage to re-establishment residual magnetism. This process is called as a field flashing method. By using field flashing method, we can develop the residual magnetism in the field poles. Next, second point. The field terminals must be properly connected with respect to armature terminals, such that the flux produced by the field current should aid to the residual flux. If the field terminals are wrongly connected, the field flux opposes the residual flux. The residual magnetism loses. There is no buildup of voltage takes place here. So for that reason, the field terminals must be properly connected with respect to armature terminals. This is the second point. Coming into third point, the total field circuit resistance must be less than the critical field resistance. The total field circuit resistance must be less than the critical field resistance. So here, first of all, what is meant by the critical resistance? Is the total field circuit resistance beyond which the generator fails to build up the voltage. See here, what is meant by the critical resistance means is the total field circuit resistance beyond which the generator fails to build up power to supply the voltage. Next, coming into fourth point, the speed must be more than the critical speed. The speed of the generator must be the more than the critical speed. Here, what is meant by the critical speed? Is the minimum speed below which the generator fails to build up of its voltage is called as a critical speed. So, if you want to build up of voltage in self-excited generator, there must be four conditions required. Condition one, there must be some residual magnetism in the generator ports. Second point is the field winding and armature should be correctly connected. The resistance of field winding should be less than the critical field resistance. The speed of the generator is greater than the critical speed. If these four conditions are satisfied, then there must be buildup of voltage in self-excited generators. And also sometimes they are going to be asked us in some question. What are the conditions fail to build up the voltage? So for that reason, again, we are going to be say that these four conditions, there is no one of the reason, there is no residual magnetism. The field terminals are wrongly connected, or otherwise, the total field circuit greater than the critical field resistance. And last point, the speed of the generator is less than the critical speed of the generator. These are the conditions fails to build up the voltage. See here, what are the questions coming in the topic in a gate? What are the questions? Previous gate questions from this topic. See here, first question. Which of the following generator will have which of the following generator will have two critical resistances? Two critical resistances. A shunt, B series, C compound, D none. So here answer is compound. Why it is compound means in compound generators there are two types of generators. One is cumulative compound generator, another one is differential compound generator. So for that reason here there must be two critical resistances. Next question. All are these previous gate questions. Next, this is the important question. A DC generator, a DC shunt generator, build up its rated voltage. If the direction of rotation is reversed by keeping the field connection is same, then the generator will A build up its rated voltage with same polarity. D build up its rated voltage with reverse polarity. C no build up of voltage. D none. So with respect to this question, what is the answer is C. No buildup of voltage. See here, what basis we can say that no buildup of voltage in the sense here. A DC generator, a DC shunt generator, build up its rated voltage. If the direction of rotation is reversed by keeping the field connection is same. So the field connection is same, but here the rotation of the rotor is rotated opposite direction with respect to original rotation. Then automatically the residual voltage developed on the armature terminals is reverse. When the residual voltage developed in the armature terminals is reverse in the sense, the current flow in the shunt field winding also reverse direction. There is a reverse field flux will be generated in the shunt field winding. This flux opposes to the residual flux. Net flux comes to zero. The net flux comes to zero in the sense there is no buildup of voltage takes place in the DC shunt generator under these conditions. For that reason here C is the right option. Similar question, second question. A DC shunt generator build up its rated voltage if the direction of rotation and field connection are reversed. The generator will build up its rated voltage with same polarity, build up its rated voltage with reverse polarity, See, no buildup of voltage, D norm. See here, the right option is build up its rated voltage with reverse polarity. See here, what basis you can recognize B is the right answer in the sense. Here, when the direction of rotation is reverse, the buildup of voltage also armature terminals is the residual voltage buildup in the armature terminal also reverse direction. And also the field terminals also reversed means changed automatically. The current flowing through the field winding also in reverse direction. So this flux is going to be added with residual flux. Net flux is going to be increases. There must be buildup of voltage across its armature terminals in reverse polarity connection, in reverse polarity direction. So for that reason here B is the right option, build up its rated voltage with reverse polarity. Next, coming into third question. A DC shunt generator build up its rated voltage if the residual magnetism and direction of rotations are reversed, then the generator will. So again same options A, B, C and D, same options. But what is the answer here in the sense? No buildup of voltage. Why here no buildup of voltage is the right option in the sense? If the residual magnetism direction direction is reversed and as well as rotor rotation also reversed. So because of this, the buildup of voltage in the reverse direction. But here the field polarities cannot be changed means whatever may be the voltage buildup across its armature terminals, that voltage is reverse direction with respect to shunt field terminals. When this voltage direction is reversed with respect to shunt field direction means whatever may be the flux produced from the shunt field winding, this flux is again opposite to the residual flux. The net flux developed in the armature winding is zero. Then there is no buildup of voltage. These are the previous gate questions asked from this topic. Buildup of voltage, buildup of voltage in self-excited generators. Next topic is armature reaction. This is very important for gate point of view. So already we know that what is the armature reaction. The effect of armature flux on main field flux is called as armature reaction. The effect of armature flux on main field flux is called as an armature reaction. See here, when actually this armature reaction exists in DC generator, when this exists, what happened to the generator or generated voltage? Here, this armature reaction takes place only under loaded condition. There is no load on generator, any generator, either maybe series, shunt and compound. There is no armature reaction. Once we connected load with respect to armature terminals, this generated voltage drive current through the load and as well as armature winding, then there will be creation of armature flux. Once there is a creation of armature flux, there is a effect of armature flux on main field flux. Because of this effect, because of this creation of armature flux, there will be some effects on the DC generator. What are the effects? One is cross magnetization effect, another one is demagnetization effect. Because of this armature reaction, there must be cross magnetization, there must be demagnetization. So what is the cross magnetization effect? What is the demagnetization effect? What happened when cross magnetization effect is existence? What happened when demagnetization effect is existence? See here, when cross magnetization effect is exist in the sense, there is a distortion of air gap flux and also sparking at the brushes. Because of demagnetization, reduction of net flux, then the generated voltage is reduced, and as well as load voltage or terminal voltage also reduces in the generator. If in a case of motor, speed increases, torque decreases. Speed increases, torque decreases. Coming to points of cross magnetization of and demagnetization. Generally see the picture here, armature reaction structure, schematic diagram. See here. Suppose there is no current flowing through the armature winding, only the main field flux is existence. That flux is flows from north to south always. This is the main field flux. Horizontal lines are main field flux. Horizontal lines are main field flux. When load is connected, the individual voltage drive current through the load and as well as armature winding. Then there will be creation of armature flux in the armature winding. Once it will be created, here this is the armature flux. So here see here, this armature flux crosses the main field flux. This is the lines, armature flux lines. These are the armature flux lines. These are the main field flux lines. Horizontal lines are main field flux lines. Vertical lines are armature flux lines. This vertically, the armature flux crosses the main field flux. Then there will be cross magnetization effect. Once this cross magnetization effect is existence, the total main field flux is going to be distortional when generator voltage also distortional. And also see here the direction of rotation of this armature flux and main field flux. So always main field flux flows from north to south. The direction of this armature flux is found by using Fleming's right hand thumb rule. Right hand thumb rule. When cross conductors are takes, these are the cross conductors. Fleming, according to Fleming's right hand thumb rule, right hand grip rule. So here when we are going to be injected right hand thumb rule, automatically the rapid fingers are represent flux direction and the thumb represents are a current direction. So for that we are going to be find out this is the direction, rotation of the armature flux in the under north pole conductors. Similarly under south pole conductors, current is leaving under south pole conductors. For that reason, according to Fleming's right hand thumb rule, here the rapid fingers represent flux armature flux direction and thumb represent current direction leading towards. For that we are going to be identify these are the directions of armature flux. So here see here at these are the tailing pole tip for a generator rotation. This is the leading pole tip for generator rotation. Here tailing pole tip here see the topmost. This armature flux is aids with main field flux. Armature flux is aids with main field flux. Then net flux at tailing pole tip is going to be increases. There will be a strengthening effect on the tailing pole tip. Similarly, see here leading pole tip. So this is the direction of main field flux north to south, and armature flux direction is opposite to the main field flux. Opposite to the main field flux means the armature flux is going to be opposite to the main field flux. There must be reduction in main field flux here. That is nothing but weakening effect. Under tailing pole tip, there is a strengthening effect. Under leading pole tip, there is a weakening effect. There is a strengthening effect. There is a weakening effect. If strengthening effect is always equal to weakening effect, there is no demagnetization. The strengthening effect is always equal to weakening effect. Means if the strengthening effect is equal to the weakening effect, the average value of flux in the each pole is same. There is no demagnetization of armature reaction. But strengthening effect is always less than the weakening effect due to saturation at tailing pole tips. Therefore, Net flux under each pole reduces, which is said to be demagnetization of armature reaction. The demagnetization of armature effect is due to saturation at the tailing pole tip. The area flux distortion more at tailing pole tip, less at leading pole tip. That is non-uniform of flux distribution, which is said to be cross magnetization effect. See here, there is a demagnetization effect, there is a cross magnetization effect. So here what happened when demagnetization effect is existence in the sense there is a net flux is going to be reduces. When net flux is reduces, the generated voltage also reduces. Because of cross magnetization effect, there is a distortion of main field flux. Because of this, the generated voltage gets disturbed. And also some more effects are there. Here see here, there is GNA axis, there is MNA axis. So GNA axis and MNA axis. Geometric neutral axis, magnetically neutral axis. So what is meant by the GNA? What is meant by the MNA? The GNA always perpendicular to the main field flux. The GNA always perpendicular to the main field flux. And also the MNA, the magnetically neutral axis, always perpendicular to the resultant flux exists in the air gap. What is meant by the resultant flux in a sense here? Under no load condition, only main field flux is there. Under loaded condition, there is a main field flux and as well as armature flux. Because of these two, there will be development of resultant flux. This resultant flux is developed. The MNA axis always perpendicular to the resultant flux. See here, the effects of cross magnetization of armature reaction. Once the existence of armature reaction, the MNA will shift in the direction of generator rotation. The amount of shift theta is proportional to the load, that is armature current. When armature current is increases under load condition, load increases, the armature current is increases. When armature current also increases, the armature flux also increases. The armature reaction is going to be strengthened. When armature reaction is strengthened, see here, the resultant flux flows like this. When resultant flux is flows like this in a sense automatically, this is the resultant flux. So the resultant flux, the MNA is perpendicular to the resultant flux. The MNA is going to be shifted with respect to GNA angle theta. Why this shifting is takes place? Under no load condition, the MNA coincide with GNA. Why? Because only resultant flux is main field flux. There is no armature flux. The main field flux is always flows from north to south. The main field flux flows from north to south. The resultant flux only main field flux. Because of that, the MNA is coincide with GNA. There is no theta is equal to 0 under no load condition. When load increases, based on amount of load connected to the generator, there will be establishment of armature flux. Because of this armature flux, there must be existence of cross magnetization effect and as well as demagnetization effects. See here, because of this cross magnetization, the MNA is shifted in the direction of generator rotation. The amount of shift is theta, which is proportional to the load, that is nothing but armature current. And also there must be increment of iron losses. Because of this cross magnetization, the commutation is also poor. The commutation is going to be poor. Why this commutation is affected? This cross magnetization effect in the sense, because of this cross magnetization cross magnetization effect, some amount of flux is going to be established nearer to the brush axis, under brush also. When this flux is going to be, flux is there under brush, near to the brush means automatically, there will be dynamically EMF induced in the brush. This induced EMF is going to be opposite to the main induced voltage. Then the commutation is going to be delayed. Because of this, we can say that there is a poor commutation. And also, there is a failure of mica insulation. Why means the armature coil which are exist under tailing pole tip cuts the maximum value of flux. Therefore, the induced EMF is maximum. If this induced EMF is exceeds beyond the particular value, the mica insulation gets damaged. So next, what are the remedies for the cross magnetization effect? These are the main effects of armature reaction. Next, remedies for cross magnetization of armature reaction. By using high reluctance pole tips, we can reduce the armature reaction. We can reduce the cross magnetization effect. See here, there is a flux is crowded in the tailing pole tip. By making some holes, we are going to increase the reluctance. When reluctance is increases, this reluctance is going to be opposes the flux, armature flux, such that there is a reduction of cross magnetization effect. And also by using choppering silent poles. This is the choppering of silent poles. Here we can increase the air gap length between the rotor and choppering pole. Automatically, when this gap is increases, the reluctance is increases. That the flux is coming from the tailing pole tip also. Armature flux is going to be reduced. Next important one is by using compensating winding. By using compensating winding also, we can, this is the compensating winding. Here the compensating winding is placed under pole shoe of tissue machine. Here the flux produced from this compensating winding is opposite direction to the armature flux. The net armature flux is going to be reduced. Then there must be reduction of cross magnetization effect and as well as demagnetization effect by placing the compensating winding. The compensating windings are used only in large machines or subjected with variable loads, but not for small machines. And even large machines supplied for steady state loads only we are going to be used. When load is changing, the armature current also varies, due to which the statically EMF induced in the coil. This induced EMF is aids with the actual induced EMF, the net voltage is increases. If it is increased beyond a particular value, the mica insulation gets fails. So these compensating windings are preferred for only large machines, but not for small machines. Next, last point, by using interpolar winding. By using interpole winding. By using interpole winding, we can reduce the cross magnetization effect and as well as demagnetization effect. The interpoles nullify the cross flux along the cross magnetization. The effect of cross magnetization is reduced, and also by reducing this cross magnetization effect also, we can improve the commutation path also. The interpoles causes demagnetization of tailing pole tip, magnetization of leading pole tip, such that the air gap flux is improved, which is become nearly flat everywhere. Here, how we are going to be connected this interpolar winding with respect to armature winding in the sense in series. The interpolar winding also connected in series with the armature winding, means the compensating winding and as well as The compensating winding and as well as interpolar winding, both windings are connected in series with armature winding. This is the very important question for all competitive exams. Next topic is commutation. Commutation process in DC machine. What is meant by the commutation? Is the process of reversal of current in the armature coil through the commutator segments and brushes is called as a commutation process. Is the process of reversal of current in the armature coil. So these are the armature coils. So this is a brush, this is a commutator segment. When we are going to be connected current from the armature winding and as well as current is given to the armature winding, there will be a commutation process. Is the process of reversal of current in the armature coil through the commutator segment and brushes is called as a commutation process. See here, generally the commutation process is delayed here because of cross magnetization effect. The commutation process also delayed. Here there is some points regarding with this commutation process. One is commutation period. What is meant by the commutation period? It is the time required for commutator to advance a distance of one commutator segment. Is the time required for commutator to advance a distance of one commutator segment. And also there are types of commutations. Linear commutation. There are three types of commutations: linear commutation, under commutation, over commutation. Here, what is meant by the linear commutation? If the current reversal takes place exactly within the commutation period, which is said to be linear commutation or ideal commutation or straight line commutation. If the current reversal takes place exactly within the commutation period, which is said to be linear commutation or ideal commutation or straight line commutation. Next, over commutation. If the time required for the current reversal less than the commutation period, then it is said to be over commutation. Next, under commutation. If the current reversal takes place after the commutation period, then it is said to be under commutation or delayed commutation. Practically, the commutation will be under commutation. Causes for under commutation is one is already we discussed, cross magnetization effect of armature reaction. Under one is reactance voltage. So what is meant by the reactance voltage? What is meant by the cross magnetization effect? The reactance voltage means when there is a current reversal takes place within this coil automatically. There is a current reversal in the sense automatically. Because of change in current in the coil, there is a alternating flux developed in this inductance. This individual EMF is going to be opposite to the main individual voltage, main collected individual voltage. Then there will be a delayed commutation. And one more also here, because of cross magnetization effect, some flux is exist under brush axis. Because of this, there will be some statically linked